Hello, my name is Steve Boisvert. I'm a knowledge-aware consultant for Auros Knowledge Systems. And today what I'd like to discuss with you is not only how the knowledge-aware technique applies to CAD applications, but I just want to clear up some common misconceptions that people often have when we discuss this topic. I'm also going to share with you some common connector practices, and we're going to look at a few different connectors to see how they interact within the CAD application. I know many of you have heard us describe the knowledge-aware technique as being very similar to navigation. In navigation, a GPS signal is used to detect where you are, and then the navigation application delivers the right directions to the user to get you from point A to point B in the most efficient way. And in general, what it's doing is it's sensing context. And based on that context, it knows which map tiles to deliver to you to get you to your destination. Another thing that's happening in the background that we really don't think about is that while we're using that application, data is being collected, not only from us, but from other drivers. And what's happening is other individuals that are using that navigation app are benefiting from that information by receiving real-time updates about slowdowns that are ahead, or maybe there's a route change that has to occur. In knowledge-aware applications like Auros, what we're doing is we're detecting context and we're provisioning the right knowledge packets, these little granular bits of know-how, into what we call an assessment control, which is our navigation app. And I'm going to go into more detail on what both of these items are. So how do we detect context? Things like what is someone working on and when they're working on it. Well, let's think about it. In today's engineering workflow, everything is extremely model-based. We use models for all sorts of applications, such as product models for assemblies, system models, the check requirements versus verifications, some validation models for simulations, operational models, manufacturing models, and of course there's the design model. And today's presentation is going to focus on the design model, but the concept of knowledge aware can be extended into any of these other workflows. So let's talk a little bit about CAD applications. Why are they the perfect place to apply knowledge aware? And for that, let's go back to context. Can we detect context within a CAD application? Yeah, CAD applications are full of data to determine context. We can tell the type of object that the user is working with. Are they working on a model, on an assembly, within drawings? Are they doing a simulation? We can also get details about those objects they're working on. There's tons of attributes and properties available, such as the material, what object state is it in? Is it a concept or is it a prototype? Is it in work? Just a wealth of information. CAD applications are ripe with content to use to detect and provision knowledge. Now, one thing I often hear when I'm discussing this concept with people is that they often say, well, we have knowledge-based engineering, so our CAD application is already knowledge aware. And the integration of knowledge into CAD application has been occurring for a long time, and knowledge-based engineering tools exist in just about every major CAD application. And there are tons of benefits to KBE, but there's also some limitations. But the first misconception I want to talk about is KBE the same as knowledge aware? And what I'm going to say is, well, not quite, and here's why. There's three key principles to the knowledge aware technique. The first principle is certainty and knowledge reuse. So does KBE have certainty and knowledge reuse? Well, sort of. For today's argument, let's just limit that focus to the CAD application, and we could say that, within that CAD application, that knowledge-based engineering tool does have certainty and knowledge reuse. The second key principle is continuous product or process validation. Does KBE do that? Yeah, it does that, and it actually does that quite well. Within those CAD applications, or really whatever application that the KBE app is running in, it will continue to evaluate that model or drawing or simulation based on that app. The third key principle is closed loop enterprise learning. And this is where KBE falls very short. Knowledge-based engineering applications is very specific to a particular CAD application. And what people do not realize is that KBE is just another knowledge silo. On the other hand, the knowledge-aware technique is based on a central repository that distributes all forms of knowledge into all forms of workflow within and outside of the CAD application. But this doesn't mean that the two concepts are mutually exclusive. In fact, many of the KBE issues like the creation, the maintenance, modification can be alleviated when KBE is combined with the knowledge-aware technique. And actually, in one of today's demonstrations, I'm going to review one application showing the synergies between the two concepts. So how does this all work? What's the details behind it? And there's three key fundamental technologies that we use to make knowledge-aware work within CAD applications, actually within any application. These are the three key concepts. The first is the knowledge packet. Second is an assessment control, which is like our navigation app. And the third is a rules processing engine. So let's kind of break these down one at a time, just to give you a little bit of background as to what they are. The first one I want to talk about is the knowledge packet. This is the what. This is the information that someone needs. This is the information that needs to be provisioned. And what knowledge packets are purpose-built units of knowledge that represent a wide array of knowledge types. Knowledge packets are typically very granular and concise. And one key element about a knowledge packet is that during the creation process of a knowledge packet, it becomes ready for reuse. It means it becomes ready to be shared into many different workflows. Now, when we're talking about CAD applications, there's a specific element within a knowledge packet that makes it very useful to share within a CAD application. And this is called a value table. Now, what a value table is basically a little mini knowledge model. And we can build these knowledge models within the knowledge packet and then distribute them into a CAD application. I'm going to go through that here shortly. But this knowledge model can execute within those CAD environments. One key element about this value table, as you can see here, this is talking about a minimum locator pin engagement model, and there's a minimum maximum. But one key item is listed there in green, and that's the parameter. That's the parameter that will get shared with a CAD application. And that parameter knows, based on this value table, how it should execute, how the rule should process. And we'll take a look at how rules process within the CAD application during our demos. So the second core technology I want to highlight is the assessment control. The assessment control is the navigation app. This is the toolkit for evaluating knowledge while you're within your flow of work. The assessment control is the workhorse that collects the relevant knowledge packet and stores information related to how each of those knowledge packets were utilized on a particular project. And like the navigation app, what happens is we can then use that information to create new knowledge and enhance the process for the next person. Now, what you're looking at here is a grid view version of an assessment control where we can see status about a particular knowledge packet. Now, when we're talking about CAD applications, we may want to take a little bit different look at these knowledge packets, especially the ones that have those value tables, those little mini models. And we maybe want to look just at the parameters. And for that, we have an alternative view of an assessment control that kind of strips out all of the other details and focuses just on the parameter and how those parameters are being evaluated within the assessment control. And this is often the view of choice for the users that are connecting assessment controls to CAD applications. So how does the provisioning portion work? Well, let's kind of go through that. So over here you see the rules engine. So we have Auros, or the knowledge repository, on the right. And then what you have on the left are the modeling tools. So either CAD application, or going back to our model-based engineering slide, we have maybe there's a manufacturing model, or a validation model, or system model. Whatever these tools are, these modeling tools, the first thing that happens is we need to detect context from those tools and deliver that context to Auros. Now what happens is when we make that connection and that context is delivered, the relevant knowledge packets are collected and made ready to interface back to the CAD application. So when we do that, those key parameters that we saw in the value table get passed from the knowledge packet, or an assessment control, to the modeling environment. Now, when the parameters within that modeling environment are matched to the parameters within that were delivered from Auros, with things such as like features or properties or dimensions, the values for those objects get sent back to Auros for validation. This is where that rules engine kicks in. So based on those little mini models, when they're tied to a parameter value inside of the model, that gets pushed back to Auros, and the rule then gets evaluated. Now once that validation takes place, a qualitative response, whether it's pass, fail, red, yellow, green, that qualitative response gets sent back into the modeling tool, as well as being stored within the assessment control. And one of the benefits of that is that you not only see status of that rule within the modeling environment, as you see here, but in the background, there's a wealth of reports that can be generated to show you the status of that evaluation, not only within the modeling environment, but also externally, which is often very beneficial for individuals that may not utilize modeling tools as their daily workflow, but they still need to know the status of a particular project. So you can see over here, there's a few different representations of reports that were generated based on information being passed back and forth from a modeling environment to Auros. Now, one key report that I want to highlight is the parameter report. And this report allows users the ability to look at how a particular parameter was utilized across time and projects. So what I'm actually showing here is an assessment control and this rule processing engine window that's open. And what happens is if you look to the right-hand side of the parameter, you'll see a little blue, some blue text that says number. And if we click on that text, what we can get to is the parameter report. Now this report is really vital for organizations to take advantage of learning opportunities that are generated as part of the knowledge aware approach. And as you can see, what's in this report is for the flange OD parameter, we can look back across time at all the values that flange OD had across various projects. And you start to see this kind of scatter plot effect within this report. And you can see at 375 tends to be the most common entered value. And at the bottom we have some mins and maxes and standard deviations there. But this information is very useful when we're talking about learning from how knowledge was applied across past projects. All right, enough about how it works. Let's talk about some common CAD connector strategies that we're going to review today. First, we're going to review non-parametric model validation. And I know many of you might be thinking, non-parametric model validation, we just talked all about all these parameters, and models are full of parameters. Why are we going to talk about non-parametric model validation? That's actually another misconception I would like to clear up, is that you don't necessarily have to have parameters within a knowledge packet or within an assessment control and deliver those into a CAD environment. There's many workflows that really do not require that level of detail and require more of an attestation of the use of knowledge than the parametric validation of knowledge. So we're going to review that based on a shipbuilding workflow, and I'll go through that process. Now the next one is freeform CAD, and I've demonstrated this strategy in the past. And freeform CAD is basically you take a model that doesn't have any parameters in it, and we kind of manually attach parameters to the model to make it smarter and also detect status against that model. And I'm not actually going to go through this particular one today, but it is a very useful CAD connector strategy. The next one we're going to go through is templates or smart parts. So this one I've demonstrated in the past. You may have seen it at other conferences. But basically what this is, we start with a smart part or a template model that is already aware of certain parameters, and then we're going to do something slightly different. Instead of using the smart part to send context to Auros, we're going to use Auros to send information into the smart part. So we're going to start with Auros first in this particular workflow, and then see how that workflow drives changes within the CAD model. And then the last one we're going to go through is automated drawing or model validation with proxy parameters. And this is a term that many of you haven't heard us use before. And proxy parameters are basically connector-generated automations. It's KBE that run within a drawing or a model. And during the execution of those automations, a parameter is created and a value is assigned. And what this does is it gives us the ability to assign parameters to objects within the CAD environment that typically do not have a parameter assigned to them. And I'll go through a demonstration of how we can utilize the benefits of attaching KBE applications or KBE automation in this particular demonstration to parameters delivered from Auros. So what are the benefits of these connector strategies? What are we going to see? And what we're going to see through these demonstrations, you're going to start to see the dynamic delivery of key parameters and rules. You'll see real-time conformance reporting happening. You'll see how the knowledge references are embedded within the modeling environment, making it very easy to get back to the information or knowledge that one might need while we're creating models or assemblies. You're going to see that closed loop learning, that third key principle that I discussed. You'll see how that information isn't just stored within the modeling environment, but it's also available for everyone outside of the tool, all these other workflows that may take advantage of it. Through some of the demonstrations, I'll show how we auto-connect to existing parameters and the relations. We're going to see new rules being introduced on the fly within the modeling environment. And then we're going to take a look at some of the reporting options and feedback that we get within the modeling environment as well as within Auros. So one of the most commonly asked questions I get when I start talking about connectors is, which CAD applications can we connect Auros to? And I typically say all of them. But if we limit it to just the off-the-shelf connectors that we have off-the-shelf connectors for several of the major applications like Creo, SolidWorks, CATIA, NX, and AutoCAD. And not only just AutoCAD on its own, but for those of you in shipbuilding, we have a connector to Ship Constructor, which, as you would know, is an overlay that sits on top of AutoCAD. And this is actually going to be one of our demos. So today, what I'm going to review with you is how the different workflows dictate the type of interaction needed by the Auros CAD connectors. And to show you that, I'm going to review 3 different connectors to see how they integrate the knowledge-aware approach. So what we're going to look at is we're going to look at AutoCAD and Ship Constructor. We're going to look at the NX application, and we're also going to take a look at SolidWorks. So the first one we want to go through is non-parametric model validation. And like I said before, this was one of the misconceptions that you have to have parameters to go back and forth between a model and Auros. And that's absolutely not true. So before we get started discussing non-parametric model validation, let me give you a little bit of background on the workflow that required it. So what you're looking at here is a Ship Constructor model. It's a 3D model, and this is actually a kind of like a section view of a vessel. Now, what many in the, I guess, mechanical design environment or workflows may not realize is that in shipbuilding, the majority of engineering actually occurs without a 3D model. The 3D model actually gets developed quite late in the design cycle, and it's mostly developed to support production, production feasibility, production engineering type workflows. The upfront work, which they call functional design, is actually done using just 2D layouts. So most of the ship is completely developed using a two-dimensional drawing. So for this particular workflow, we did a project with some shipyards, and one of their pain points was that when they develop these 3D models, there's so many of them, and ships have tens of thousands of parts. And before they go out to be produced, the shipyards want to go through and do a quick basic validation of that production part. They're not so worried about the shape of the part as much as some of the other features about the part, maybe some of the attribute information about the part. And so what they do is they basically employ a variety of people to open up each one of these parts and then do their own evaluation. And what was happening was each individual kind of had their own process. They had their own criteria for what they were evaluating. And what happened was there was a lot of variation. There were some reoccurring mistakes that were occurring, or that happened. There's just not enough standardization in the process. So what they asked us to do is build a connector into this environment that would allow them to standardize that process and allow each individual that was checking each of the components, give them the same criteria for what to evaluate. And for that, like I said, this particular workflow wasn't so concerned with the shape of these items, but more of other criteria that didn't require parameters. What you'll see is inside of Auros is, I'm going to start with the knowledge. So what was created? So we have their knowledge repository, and what you'll notice is that these validations that they do not have value tables. I mean, this is a very simple check. Check the thickness, penetration, and material properties, but there's no value tables. So what we're going to see is how the Auros connector delivers knowledge, provisions knowledge in that workflow. And the first thing that the users do is they have to set up which knowledge do they want to provision into the workflow. And for this, we define our knowledge source for detailed design. Another thing that they may want to do is to link certain CAD properties to certain Auros properties, which they can do here from this mapping window. And what happens now is when the checker goes into the CAD environment, they select an object, like we're doing here, and they can right-click to get a list of menus. And what I want to show you here, let's talk about context. If we look at the properties, this particular object is full of information we can use to detect context. Things like its property type, its status, its thickness, its material, all that information's here. And for this workflow, what we need to know is whether it's a structural element, and based on that, and which level, is it a part level? And based on that, what we can do is the users can create an assessment control. We can provision context of it being a structural element at the part level, send that to Auros, and Auros is going to allow them to develop an assessment for that object. And what you can see when we selected create an assessment, the assessment collected the right knowledge packets and delivered them back into the CAD environment in the form of an assessment. So let's take a look at this real quick. So what happened now, if we look at the Auros properties, we can see that an assessment was created on that part, it's evaluation ready, and the overall roll-up status is white or not evaluated. So now, when we go in and we open the assessment and we start to evaluate it. Remember, we're just going to attest that these things are right. So for my demonstration, I'm not going to put a lot of time into it. I'm just going to select some statuses, red, yellow, green. Maybe make this one green, and we'll do this one green, and now everything's complete. You see there's no more not evaluated. We can look at the header of the assessment, and we can see that information from the part was sent to Auros and stored within the assessment, like the part GUID, or basically the ID for that part stored there, as well as some other information, the product or project code. But if we go back and look at those properties, what happened? We still have the assessment ID, but now the status is yellow. So when I was doing that evaluation, this part became aware of its rolled up status. So it's very beneficial to the individuals that check these components, because now that information is stored within the CAD application as well as within Auros. So if I wanted to report on which components have I checked, which ones haven't I checked, what are their statuses, I now can very easily see which ones were evaluated, which ones were not, and what the status of each component was. So not only did we standardize the workflow, but we made it very efficient for the different checkers to get to that information and utilize it within the CAD application. Now, the next demonstration I want to go through are template or smart parts. And for this one, I'm going to use NX, and then we're also going to see a little bit of this in SolidWorks. So for this demonstration, we're going to start off in NX, and what you're going to see are two simple hub flanges. The one on the right is the actual part. The one on the left is just a dummy part. That's just a clone. And I do that so when we push information in from Auros, you can see the changes. So this workflow is a little different. We're not using the CAD application to sense context. We're going to start from Auros to send information into the CAD model. And what you're going to see is the CAD model is already aware of parameters. You can see in the sketch here that the sketch already is aware of the parameters I'm going to send from Auros to the particular model. So we're going to go to Auros, and for this, we're going to open up our hub demo, and I'm providing context. So I know I have a circular smart part. So for this, I collect the right knowledge packets related to the circular smart part, and you can see some of those here. And what you'll notice is that the value table on all of these knowledge packets is completed. So there's some logic or many knowledge models that have been built into every one of the knowledge packets. So if we build an assessment control, we take that collection of knowledge packets, and we're just going to give it a quick project here. I'm going to give it a description of 15,000 Newton meters. This particular workflow is very reliant on the torque. So I have my assessment control in the detailed view, and if I click the little processor, I'm going to put in my inputs. What's my max torque, 15,000 Newton meters. Maybe I got that from the customer or the sales team. But now that max torque is then sent into all of the other evaluations that need that input, and I'm able to start creating and generating values for all the different features of the model. And like I mentioned before, one of the key views for CAD applications is the parameter view. So we switch over to the parameter view. I'm looking at just the parameters that are needed. And I can see on the right-hand side, what are the computed values, what are the max and mins within those computed values. So I'm filling out my, whatever you want to call these, maybe these are best practices or it's the design guide. I'm going to fill that out, and then I'm going to go to my CAD application. Now within the CAD application and within NX, we're going to go to Tools, we're going to open up our Auros connector, and then we are going to tell the Auros connector which assessment to connect to. So we're going to connect it to assessment 468. And if we look at assessment 468, here's that 15,000 Newton meter flange, and everything is filled out. Everything is green, meaning I'm meeting all of my best practices. What the system expects me to have, that's the values I'm providing it. So now within the CAD application, I want to look at the parameters. I can see the values in the model are not the same as the values in the assessment. So like flange OD is 260 in the model, 375 in the assessment. So I'm going to update the model from the assessment. I'm basically going to push the values from the assessment into the model and see how it reacts. So when I do that, the model updates. And what you're going to see is the status of that information has been provisioned into the model, and I can see the status within the part navigator. Here's all my greens. Here's my links to my knowledge packets that are in that assessment control. So here's some of the parameters, like the flange OD that we've looked at before. And what happens now, we talked about continuous product and process validation. What happens if I change this? What if I decide to make it 450? So I can change that within the model. The model is going to let me do that. And what you'll see is the flange radius increases. And what happens now, if I look at the part navigator, my visual indicator of status now shows me that I'm red. And it's also providing me with some information. So it's telling me that my max should be 393, but I'm currently 450, so I'm failing, which is very beneficial information to someone working in the design environment. Now, maybe this person is like, why is that failing? I want to open this up and see what the knowledge is. So we want to get to those embedded knowledge references. So right within the tool, we can quickly get to the knowledge packets that contain that information. Maybe there's other information on the knowledge packets that we need to be aware of. So I'm going to set this back to 375, and the model is going to update back. And what you're going to see is I'm now back to green. So let's switch over to SolidWorks. Same kind of model. Same setup. I have my global equations here. I have max torque, trunnion OD, the same criteria that I just saw in NX. If I look at my sketch, same thing here. I have my sketch defined. I have those sketches linked to the parameters. So let's open up our Auros connector. We're going to open up our SolidWorks connector. Looks slightly different than the NX connector, but that's okay. What we're going to do is link it to that same assessment, 468. So I'm going to load that. It's going to tell me, do you want to apply the changes? Yes. Same thing as in NX, what you see on the far right-hand side, the model value and the reported value, and they're not the same. So I'm going to update the model from the assessment reported values. So you're going to see in the model update, and now I've just utilized the same knowledge within two different CAD applications, two different models, same common knowledge set. This is extremely beneficial to, I know a lot of our tier 1s and tier 2 suppliers that we work with in the automotive business. Many of you support multiple CAD applications, and many of you support KBE within both of those CAD applications. So what you really have is redundant knowledge, which makes it very difficult to modify. If you modify one, you got to go make sure you modify the other, so things become out of sync. So one of the key benefits with the knowledge-aware technique is it becomes CAD agnostic. It doesn't really care which CAD application you're in. The same knowledge packets can be shared across all of the CAD applications, leaving you with one core set of knowledge to be managed. It gives you that single source master. So if you have to make an update, you update it in one place. All of your downstream workflows will benefit from just that one update. So very efficient in terms of maintenance and even creation. All right, last demonstration. We're going to talk about automated drawing and model validation using those proxy parameters. So real quick, let's talk about these proxy parameters again. These proxy parameters are basically KBE automations that are going to run within the model, and then we're going to tie parameters from Auros to those objects. So for this, I have just a real simple part. It doesn't matter if it's a part or assembly. There's no built-in parameters for this one like I had on the last one, but if we look at the part properties, there's still a ton of information I can use to detect context. All of these part properties can be used. And for this particular demo, I'm going to focus on the state, the concept. Its particular objects is in the concept state. So for this, I'm going to open up the Auros connector. And what you're going to see is that there's, it's already linked to a set, basically some knowledge already assigned to it. Now, if we look at the settings, you're going to look at these Auros automations. So you're going to see here the KBE, knowledge-based engineering automations that exist within this model. So is the sketch fully defined? Are there suppressed features? Are there errors and warnings? So what that is an automation that can run, the error and warning one will detect whether there's that little symbol there in the sketch. So it'll go through the part history, look at the sketch, each sketch. If it finds that, it creates a parameter with a value, and we can attach a parameter to that and then do some rule processing. So now what we're going to do is, for this particular workflow, we need to build an assessment. So I'm going to create and use a new assessment. So my fake project, I'm going to give it a quick description, 2019 conference demo, and I'm going to create a new assessment. Now what you're going to see is immediately what happened was there's a change. You may not have noticed it, but there's a change. That original check now changed to a material check. And this is based on one of the automations that we had, I just showed. Based on the use of an assessment, if the model is in concept stage, it wants to look for the material and make sure the material is an approved material and material finish, which it has done. And that's all done based on the use of metadata on each of the knowledge packets within Auros. So now, if I go up to the part properties and I change my state, I'm going to change it to in work. Right? So I'm changing my model properties, I'm changing context. And if we take a look at the connector, when I change context, what it's doing is there's another automation that's going to run looking for in work. It's going to go off and find all the knowledge packets that are related to the in work state and deliver them back into my connector, into my model. And you can see that many of them auto-evaluated themselves based on the information that it found in the model. Some of them are incomplete, and some of them have evaluated to green, some of them evaluated to red. And if I want to take a look at the embedded knowledge reference, I just click on the link to the knowledge packet, and I can see that this particular one has been assigned metadata attribute of in work. And if I want to update the assessment, I can either set up some criteria to do it on load or on model changes, or I can manually push those changes into the assessment. And you can see the values from the connector have been pushed into the assessment. So here's that red one we were looking at. Are the sketch fully defined? It's picking up a value of no, as we saw that the sketch wasn't fully defined. And if we want to look at the dynamic delivery of knowledge, you can see all these knowledge packets added into the assessment when all I had to do was change context, and it brought all of this information in dynamically into my model. Very beneficial. There's a lot of power in connecting not only knowledge to the CAD environment or model environment, but also connecting knowledge-based engineering automations to the knowledge-aware technique. A lot of power there. You can see how quickly things are evaluated, how dynamic the knowledge delivery can be within the modeling environment. So what do we cover? Is knowledge-based engineering the same as knowledge-aware? It's not quite the same. There are benefits to KBE. There's a lot of benefits to knowledge-aware. And there's even more benefits when you connect KBE to the knowledge-aware approach. We took a look at some of the workflows. We looked at the non-parametric model validation. A little bit less fidelity into that workflow because it does rely on some attestation, but still very beneficial. There's a lot of efficiencies there. There's some standardization, all the reporting that occurs. If there's any new knowledge, there's a place for it to get delivered into so that synchronization all happens. Freeform CAD, another valid workflow that didn't show. If any of you would like to see demonstrations of that, I can do it. Just contact us. The smart parts, the smart templates, you saw that one with the hub flange, starting from the assessment control. So we define the context and deliver that context to the CAD application. And then we saw how the model responds to changes, not only within NX, but also the same use of the same knowledge within SolidWorks. And then we looked at the automated validation using the proxy parameters, so connecting those KBE automations to the knowledge-aware parameters. And we saw how those things evaluate themselves, how there's the dynamic delivery of knowledge into the CAD application. So just a quick summary, what are the benefits of applying knowledge-aware within CAD applications? I go back to those same three principles. You get certainty in knowledge reuse. You get that continuous product or process validation. Those rules are going to continue to evaluate those models as the model changes. And you get that closed loop enterprise learning. All of this information in the knowledge-aware approach isn't just siloed within any one CAD application. You have that central repository that can not only deliver across CAD applications, but even into workflows outside of those applications. All that information and knowledge becomes available to all these other external workflows. Very, very beneficial. If anyone would like to see live demonstrations, feel free to contact us at Auros Knowledge Systems. I'd be happy to come out and show you the execution of these workflows in a more live and dynamic way. Thank you for watching. I hope you enjoyed the presentation.